Today we are going to talk about datums. So we've talked about datums a little bit before. We've talked about when we're doing baseline dimensioning that all the dimensions are essentially coming off of a datum. But in geometric dimensioning and tolerancing, we are more specific. We actually call out the datums. And then sometimes we will have some GD&T that reference those datums as well. Today we're really going to focus on calling out the datums, and then next week we'll actually do some control frames that reference it. But I'll give you a little preview of that too as well. So the datum is kind of a theoretical line or plane that the part would be pressed up against, or in some cases it's a real thing. If we're talking about a table saw, for example, you're going to put the part on the table saw first, so that's your first datum, and then you're going to slide it against the fence, so that would be a secondary datum as well. We'll look at 3 datums when we're fully laying out a part here. A datum feature could be a part or a feature on the part itself that acts as a datum. So for example, a cylindrical feature could be the datum. So the center of that cylindrical shape is what we want to reference other things to. And the difference there then is we would attach the datum call out to the feature itself, not just to a face. So again, if I've got a datum plane here, again this could be the top of a table and the part is sitting on it, so this would be the primary datum. Again, the idea that the parts aren't exactly perfect, so technically the whole place or the whole plane doesn't sit on it. There might be individual points that hit it first. So we're talking about 3 different planes. Again, using the table saw example, I set it on the table itself, and then I slide it up against a fence. But then when my part is finished and I want to line it up with 3 planes, then I would have a third plane that I will line it up with. Now it could be any 3 planes. We'll see some drawings today where it will call out exactly which planes that you're going to work with. But in keeping with the idea that these parts aren't exactly perfect, if you think about it even from a microscopic level, there's all these different points that are sticking out different distances. And so when you're placing it on the first point or first plane, it's basically making a 3-point contact. So again, with all those different microscopic variances in the part, 3 points are going to be touching the plane. If I had 2, it would wobble, right? So if I had, as soon as it finds 3 points that it can touch, it's going to be nice and steady. Then when I slide it up against the secondary datum, it's going to have a 2-point contact. So 2 points is all that's needed to fully lock it in. And then when I slide it to the third datum, it only needs 1 point. So sometimes, again, it's kind of a little more conceptual because we're thinking about the microscopic differences. And then other times we're going to actually have some datum points that we're going to actually line up, or little, what should I say, pegs. We're going to have some pegs in one of the examples that we'll be pushing up against. This is our symbol for the datum plane. I'll show you how to make it in just a little bit. It'll be a combination of a leader and a feature control frame. And then when we're placing our datums, here's some appropriate methods for placing it. First of all, you'll notice that even though it's kind of a leader, it is a straight horizontal or vertical line, or sometimes it could be both. You could have a horizontal line and a vertical leader, or vice versa. So if I'm calling out surfaces or lines, then we put them either on the surfaces. Notice that it reads from the bottom each time, but the leader can attach in either direction. Also notice that this is open. The ones we'll use are filled, so you'll see them as either open or filled. And then again, oh, go ahead, Keith.
Is there a difference between that?
No, it's just different, different symbols, but we'll use the filled one. You notice the B, we've got a little extension line carried out, and it's on there indicating that this is datum B. And then same thing on the extension line here for the dimension, so the top of this part is plane A, datum A. Now if you look over here, this is if I'm calling out features as datum. So in this case, this circular hole is going to be datum A. So I've got the call out of the size, I've got the location We haven't really talked about location yet, but I've got the location feature control frame, and this is datum A. So if I have another hole that needs to be a certain distance away from this one, then it will reference datum A. So that's why the feature itself is the datum. So in this case, the outside cylindrical shape is the datum. You can see B attached there. Here we've got the hole called out, and then the datum sitting on the extension line. And you can also line it up with a dimension. So if you compare this one over here, where it's on the extension line, but it's not lined up with the dimension, and then here it's lined up with the dimension, so it's actually calling out the feature as a dimension. And if you don't have enough room for all that, then you can actually replace the arrow. You can explode your dimension and replace it with the datum symbol as well. You can see that on this feature also. So again, we're not going to put these in the control frames just yet today. We'll do more of that next week, but this is where they'll show up. We'll have our primary, secondary, and tertiary datums and call them out as A, B, and C. These are the ones that we're going to do. I'll jump to them in just a moment, but I wanted to look ahead a little bit and give you an example of how the datum's used. So for example, the bottom surface of this part is datum A, and then I want to put an angularity constraint of 0.002 on this surface relative to A. So that's how we'll eventually use these datums. Again, today we'll just focus on calling datums out. So these are the 4 that you're going to do. There's templates already in there. Let me show you a few things here, starting with the first one, 213. So these are all from chapter 16. So the instructions for this one tell you to draw the front and top views of the stand and model space and add the information shown on page 604 in your book. And the viewport scale is 1 to 2. So you can actually either draw inside the viewport, or you can go over to model space and draw it down below as well. In terms of actually putting in the datum, let's look at that. So let's say I have a rectangular shape and I want to call out the top as the datum. I don't think I've got the style set up in here. Oops, wrong one. So let me show you how to set up the style. I basically have you set it up once or twice, and then I start including it in the template so that you don't have to do it every single time. So it's part of a leader style, and I'm going to put these in the dimension layer so that it will print thinner. And I'm going to go into my leader style. So to get to leader style, I'm going to hit my annotation drop down, and then hit my leader button here. And then I'm going to create a new style, and I'll just call this GDT or datum or something like that. And continue. And then I'm going to come over here to the leader format. So right now the symbol is set to closed filled. I can do the datum triangle. So you can see there's either a filled or a not filled. And again, we'll use filled in here. And then, I can't remember if I constrained the angle or not. I don't think I did. Per segment angle, well, no, because that would lock it in horizontally. So let's stick with that for now. I think that's all I did on this one. So now, it's just a simple matter of using the leader with the correct style. And I can create my little symbol. Now you can see you can go at angles, but again, we typically go horizontally or vertically. And you can see that it creates a little landing for me. I'm just going to click to get rid of the text. And if I didn't want the landing, which actually, now that I think about it, is something I did change on my other template, because most of the time you won't need it. I'm going to modify this and turn off the check for automatically include landing. There we go. So that one looks weird since I had the landing on it. So now I'll do it again. And now you can see there's no landing. It's just the triangle and the line, and then I'll click away from it to not have any text. So again, you can go horizontally or vertically with these. If for some reason you do need an extra little leader, you can always draw in just a simple line and have an extra little leader. Then for the datum itself, you're just going to use the feature control frame again. So I'm going to go to the Annotate tab, the Dimensions drop down, and the Feature Control Frame. And I'm just simply going to type the letter in the Datum 1 box. So even if it's datum B, I'm just going to type it in the datum 1 box. Then I will get my little datum. So if I want to have another one, then this one's going to be B, then I can have that there. And then I'm just going to move it into place, snapping to the midpoint to place them precisely. So again, this A, I threw that extra leader in, but it could also, oops, be lined up over here on the left. Interesting, it's not letting me grab the midpoint. Huh. But it will if I grab the grip. That's interesting. So that is the proper way then to call out your datums. So let's look at these in the book. So this is the first one that it's referring to. So you're going to do a top view and a front view of this one. And it tells you that you need these geometric tolerances applied to them as well. So it says the bottom is your primary datum A. And by the way, calling out datums, we're calling them out in edge view. So just like when we're calling out surface texture, you should be showing them for its edge view because you're just pointing to the edge. So just to make sure I'm clear on that, if this were a 2-view drawing, and this were my front view, and I said, okay, the top is datum C, I would not create a leader just onto this surface. I instead need to attach it to the top of the part here when it's in edge view. So either I need more space between them, or if that's not possible and I've got a dimension here, then I can go ahead and pop it onto the extension line. Remember, I'm not going to put it right here. I'll only do that if I'm told that the part itself is the datum. If it's just the surface, and then I'll bring it out like so. Let's see, so it tells you what your A, B, and C are. It tells us the bottom is to have a flatness tolerance of 0.003. Again, we're not relating, flatness doesn't relate to any other datums, so you're not going to be putting datums in your control frames yet. And then it says the diameter of one hole, which is actually, as you can see, you've got a tolerance applied to it, to have a straightness tolerance of 0.002 at MMC. So that means straightness, 0.002 MMC. Let me ask you guys a question. And that question is, straightness, tolerance of 0.002 at MMC. Is that the correct call-out? Remember that when I'm applying the straightness to a cylindrical shape, I'm applying it to its axis. And remember my inventor example of how that ends up being a cylindrical shaped tolerance zone? So what do I need in here to indicate that?
Diameter symbol.
Thank you. So that would be the correct call out for your straightness. And since it's a feature of size, you're just going to tuck that right underneath your dimension. All right. So the second one, the instructions are a little odd on this one. In fact, I second-guessed myself and scratched some things out on here. But what we're looking at is, this is basically our gauge, if you will, and this is the part you're actually working with, and you're going to set this gauge on this part. So when we think about the primary, secondary, and tertiary datum, if I'm sitting this on this table, then would you agree that the bottom of this part is the primary datum? So I'm setting this on the table, so the bottom of this part is the primary datum.
Okay.
Does that make sense? And then I'm going to slide that against these two pins, so that would be my secondary datum. And then for my 1 point, that's going to be my tertiary or third datum. All right. So it's a little weird because it says the top surface of the base plate to be datum A. Again, that's the top surface of this, which is going to be the bottom of your part. So make sure you call it out as the bottom. And then it has a flatness tolerance of 0.2 to the back surface of the part. So this being the back surface back here. Now over here, they're just simply asking which, if any, of these is a good part. And you don't have to do this, but let's talk about it together. So it's really focusing on this shape right here, which is right here. We're not given any sort of straightness value on that. We're given a flatness on the back, but then we are given just basically the tolerance here of 25 plus or minus 0.025. So this could vary based upon that. So if I'm looking at this first one, it's between 25 and 25.03. This is 24.75, 25.25. So both of those values fit within that range, right? So it would be a good part. So this one starts at 24.75, which would be my low end. This one exceeds the 25.25 of my high end. So is that a good part? No. And same thing here. The 25 is right in the middle. The 25.3 is above my 25.25. So that one's not a good part either. So again, you don't have to do anything on your drawing for that one. Something for us to talk about. So on this one, again, there's a template already there. When you start it, it'll just be another blank one. And again, it just tells you to draw the front and the top. Let's see if I added in the style yet here. I did. So I just called it GDT. So really the first one, I just wanted you to have a little experience actually creating it, and then they should be available in here from now on. So the third one is page 605, number 16-215. And it's a metric one. We don't do a whole lot of metric drawings in here, but this one will work okay. So we're going to draw this in model space, and then add the appropriate dimensioning, and then you'll see the, let's see, all datums and tolerances to be on an MMC basis unless otherwise specified. So you'll see these notes. I didn't mention earlier. It says that here as well. So that means when you do your flatness, you'll put in the MMC symbol. Okay, so same thing here. MMC, the diameter 44 is datum A. So this feature is datum A, so you'll attach the A to this leader, if you will, or again, to the arrowheads, however your dimension ends up. The end face of the diameter 90, so that's talking about this one here, is datum B. And then the width of the slot is datum C. So this 18 up here, you would attach your datum C to that one. The end face, so they're referring to this one, is to be flat within 0.25. The center line of the diameter 44 must be straight within 0.1 regardless of feature size. So the center line of this is the same thing as saying the axis, same thing as saying it's the feature. So you're going to attach it to the value there. And the surface of the diameter 20 is straight within 0.2. So just calling out the edge there. Then the last one you're going to do is this one down here. And again, this time you're going to create 3 views. And then once more follow the instructions, and once more they're all MMC unless otherwise specified. So you'll put in the MMC symbol. All right, well that's the plan. Let me know as you guys run into any questions. Those are all in the, what is it, 16-5 folder? Yes, thank you. So templates and chapter 16, 16-5. So also do your dimensioning as well. So do your dimensioning and your geometric dimensioning and tolerance. Let me know if you have any questions.